Okay, welcome back, Chemistry 30. You had a chance, hopefully, to look at this. I've finished working out 6B with you, so that leaves 6C, E, F, H, I, J, K, L for you to do. Now we'll look at questions 7 and 8. We're actually going to combine them into one question, because question 7 is devise a procedure to separate these, and then 8, we're at the net ionic equation. So what I'm going to do is I'm going to do question 7A with you. And it's looking at separating two negative ions. Then that'll leave you with B and C to do. Then I'll look at, okay, what's it like when you try to separate two positive ions, and then leave you with E and F. Okay, so I'll give you one, I'll do one of each type, and then leave you with the remaining ones to do. So here, devise a procedure that enables you to separate chloride and phosphate from each other. Before we do that, we should look at what in fact we're doing here. It's qualitative analysis, determining what ions are present in a solution and looking at separating them by selective precipitation. So making one of them turn into a PPT, filtering it off, and then leaving the other ion in solution. That's in fact what we're doing. Now, one thing that I got you to label on your chart was circling the alkali metals and circling the nitrates. So if we look back at that, let's see if I find my chart here. Circling the alkali metals, circling the nitrates. So if we take a look at that, that's very important for when we're trying to figure out how to shuttle in certain ions to make a precipitate. So make this little note here, get this down. When you're separating cations or positive ions from each other, remember that alkali metals are soluble. When separating anions or negative ions from each other, remember that nitrates are soluble. Okay? So, first of all, questions 7 and 8, a couple of hints there. We're only making one ion precipitate. Don't make both of them precipitate, because then you can't separate them. The idea here is that we're going to separate them. Imagine this with this first example, chlorides and phosphates. We have a beaker of chlorides and phosphates, and of course other things as well. But we only want either the chloride to precipitate or the phosphate to precipitate. Okay, so that was the question here. Chloride and phosphate, we have to separate those by making one of them precipitate. So if you look at the chart, chloride precipitates with these four. Phosphates, alkali metals, and ammoniums are the only thing that don't precipitate. So pretty much everything precipitates except these. Okay? So all I did here in this question was just simply write that down. Write that summary down. Chloride, things that make it precipitate are silver, lead 2, mercury 2, and copper 1. Phosphate, everything is a precipitate except alkalis and ammoniums. Okay? So there's a problem here. If we try to precipitate the chloride by adding silver, guess what? Phosphate will precipitate as well. Lead, it'll precipitate as well. Mercury 2, mercury will cause so you can see all of these will make both of these precipitate. So the key thing here is that we can't cause a precipitate with chloride, because it'll make a double precipitate with phosphate. Okay, so that tells us that, okay, we can't precipitate that, so maybe we can precipitate phosphate by picking anything that doesn't cause chloride to precipitate. And if we look at our chart, there's virtually many things we can use. We can use calcium, because calcium isn't in this list, but it falls into this list. Strontium, same thing. So there's tons of combinations, and that's what this assignment deals with. You'll have a different answer than your buddy or partner, because there's virtually many combinations. So when I mark this, I'll actually go through your process to see what in fact you used and whether that actually works or not. Okay, so I made a note here. We need to cause phosphate to precipitate. I chose barium. Barium's not in this list, but it falls into the category of anything else that isn't an alkali or ammonium. So we have to have a way of bringing that barium into this beaker here in terms of a compound. So notice I set up here, if we're separating negative ions from each other, such as the case here, remember, nitrates are soluble. So I can transfer those bariums in there if I have a barium nitrate solution. So that's a way, nitrate is a way of getting these barium ions into there. Once the barium ions are in there, I know that the barium and the phosphate will come together and make a precipitate. Barium is 2 plus, phosphate's 3 minus, so 2 and 3 both go in the 6. So the formula there, to make 6 bariums, I need 3 of them. To make a charge of -6, I need 2 phosphates, so you need 3 bariums, 2 phosphates. That's my net ionic equation. Then lastly, just have a statement saying, okay, I have that now. So I'll have a barium phosphate precipitate form on the bottom of the beaker. Then all I need to do is pour that through a filter, filter out the barium phosphate. It'll stay as a solid in the filter paper, and the chloride ions will just go right on through. So there you've answered the question. You've separated those 2 ions from each other by precipitating one of them. Okay, so B and C are very similar. Whatever ion you pick, you're going to transfer it in there using the nitrate ion, and basically the same type of process there. Okay, if we look at question, so basically there's 3 marks I'm going to give you for that question. 1 mark for picking the right ion and transporting it in, the net ionic equation, and then saying the filter out statement. Okay. I'm going to also go over 7D, one that involves separating positive ions, and that'll enable you to do E and F. So let's see here, it is lead and magnesium. So lead and magnesium. So if I take a look here, I'm going to be working at this backwards. So lead and magnesium. Finding lead and magnesium in this area here. This sticks out automatically. I see lead makes a precipitate with one of these. And notice magnesium isn't here. So I could use this. Lead or magnesium. There it is. There's lead. I could use sulfate because it'll precipitate lead and not affect magnesium. But look, oh, there's magnesium. It's soluble with sulfide. Lead 2 falls in the category of here, so I could use this. I wouldn't be able to use hydroxide because lead and magnesium fall into the category of anything else, and lead and magnesium fall in the category of anything else. So there's 3 options there: chloride, bromide, or iodide for that group, or sulfate, or sulfide. All of those make a lead precipitate. So once again, it's up to you to determine what you want to use. So I chose to use chloride. And that note up above, this time I'm separating positive ions from each other. So if you are separating positive ions, remember that the alkali metals, sodium, potassium, lithium, etc., are all soluble. So it's a way of transporting those chloride ions into there. I need something positive, a compound, a bottle of a chloride compound to transfer into there. So I just chose potassium because it's an alkali metal. I could have chosen sodium, it doesn't really matter. So add chloride ions in the form of KCl to cause the lead ions to precipitate. So the Pb and the chloride ions, as we've seen earlier in the assignment, make a PPT. So lead is 2 plus, chloride's -1, so of course the formula there for the lead 2 chloride precipitate, PbCl2. And showing the ions, I'd have to have 1 lead ion and 2 chloride ions to come together to make that precipitate. And then lastly, filter out the lead 2 chloride precipitate, leaving magnesium ions in solution. Okay, so that's how you do it. It's kind of reverse for questions D, E, F. So I've done A and D. You can always look back in this video if you're running into a struggle just to see the method there. Otherwise, you're able to do 7B, C, and E, F. And again, 8 is just that net ionic equation. We're doing it all in one big question. Okay, so 6, 7, 8, the ones that you see here that aren't circled, those are the ones that you need to do for the assignment. Okay, we'll see you again.